In this section, we are going to understand by writing a unit testing contract how to do testing using JavaScript. So we just saw what is the importance of doing testing for any program, and we also saw how to do it in Solidity. Just theoretically, we did not write anything, right? Because test scripts are not so complex. Ideally, it should not be complex at all, right? You should split your application into multiple small parts so that you can check each and every small part, and then you will be sure that your application is working perfectly fine, right? So if you look at this project, let me download a box called as MetaCoin. So MetaCoin is a truffle box which has some test scripts within that itself. So we can go through that test script and then write a test on our own probably to understand how we can do it. Correct? So let me create a new folder called as mkdir MetaCoin. Go back to this MetaCoin, and here I can say truffle unbox, just like we did for React before. We can say truffle unbox MetaCoin, right? So this is going to download the MetaCoin box for us, right? So let me see what is there in MetaCoin. So here you can find that truffle config will be there, and as usual, let's including networks you have to do, right? So yeah, this is where I close my network, and here it is 7545, so we can leave it just like that, not an issue, right? And then we'll also see the contracts. You can see there's a contract called as MetaCoin. Okay, so this MetaCoin is nothing but a very simple token, right? So if you compare it with ERC20, we have a mapping with from address to event of balances, right? So the constructor is just going to give 10,000 coins or tokens to the balances, right? I mean the transaction origin. What is this transaction origin? It is just like message.sender for now. Remember it that way. During security analysis, we are going to look at more of it. Okay. So transaction origin is like message.sender now. And there's a function called a send coin. So to the receiver amount, it's equivalent to the transfer function that we have in ERC20. Okay. So reduce the balance, increase the balance, and emit the transfer. Right. So now we have two retrieval kind of what do you say, the functions. So if you say get balance and you pass in an address, it's going to give you what is the balance that the address has, right? Another one is called as get balance in ether, and if you pass address into this, it's calling convertlib dot convert get balance of address, that's calling this function, and 2 is being passed. So what is this convertlib? That is imported from another Solidity file. Okay, look at convertlib.sol. This is a convert library, right? This is going to convert whatever amount you give, and conversion rate is going to multiply that and give back. Correct? So it's a very simple process that it follows. Yeah. So that is how convertlib is also present here, right? So for this contract, for this functionality, we have to write a test script, right? So if you look at test MetaCoin Solidity file, we have test initial balance by using deployed contract and test initial balance with new MetaCoin, etc. So very limited functionality. What they're doing is just creating a new MetaCoin instance. Expected is 10,000. Call this meta.getBalance, right? And expected. Yeah, they're comparing if it is correct or not, right? So that is the max that can be done in Solidity, but JavaScript provides a lot of advantages for us, right? So let me just bring it down and close this as well. Yeah. Now, again, just like we did for our deployment or migration script, we will do artifacts.require MetaCoin, correct? It will go to the build folder, bring MetaCoin and all, right? And I'll create something called as MetaCoin, pass in some accounts. Accounts are coming from the wherever the contract has been deployed to. Okay, so it is going to go there. And whenever you look at it statement, right, in JavaScript testing, this entire thing is one test case. Okay, so first we are saying should put 10,000 MetaCoin in the first account. So whoever is deploying, it should give 10,000 MetaCoins to that account, right? That's how we make sure that the constructor is working. Second, it should call a function that depends on a linked library, that get balance in ether function, right? This one, if you look at, is calling a convert library, right? So we are going to test if that is working. Okay, it should send the coin correctly, so we need to check if this send coin function is also working properly, right? So that is how you write test cases for all of the functionality that is there in metacoin. Okay, so if you look at how to run this, first let me run this and show you, and then we can go through the contents of this JavaScript file one line by other, right? So to test this, you will just say truffle test. So remember, truffle init, truffle compile, truffle migrate is what we have seen. Here we will see truffle test, correct? So once you go to truffle test, it's of course going to compile your contract to get the artifacts, right? Then it's gonna compile, that's done successfully. Then it's gonna say test metacoin. One thing about truffle test is that it will go to the test folder and test all of the contracts, okay, all of the test cases. So we have two files, right? One is test metacoin.sol, right? That's the solidity testing. These two are solidity test cases, okay. But what we are focused on is the metacoin, which is the JavaScript test case, okay. So here it says contract metacoin from here, correct? Contract metacoin. So first case should put 10,000 metacoin in the first account is passing because it shows a green arrow mark, right? And should call a function that depends on a linked library is also passing, and should send coin correctly is also passing here, right? So that's the concept of testing and how to do it. Now let me take you through the cases. First thing it says should put 10,000 metacoin in the first account. So first I have to deploy it. So metacoin.deployed. So this deployed is going to take the instance that has already been deployed. It uses the development frame network and everything, right? Metacoin.deployed. I'll take the instance. Now after I get the instance of metacoin that has been deployed, I'll be able to call all the functions in that, right? So I can say metacoin.instance.get balance. Get balance is the function. Dot call, because it's a view function, one parameter, I'll say accounts of 0, right? So this is going to give me the balance, correct? So I'll say balance.value of, just to make sure that the format is not changing, correct? It can sometimes give a string also, right? And compare that with 10,000. So I can be sure that if the accounts of 0 and the function is returning 10,000 and whatever I am expecting as 10,000, because I am the person who wrote the contract, right? If it is equal, assertion means you are checking two things, okay. Dot equal means the first and the second argument which in this should be equal, and this is the error statement, okay. So if you make this 9,000, right, and call truffle test, one of the test cases is gonna fail. So let's just wait for that to complete. It is compiled now, and then this is the solidity test cases that's being tested first, and then it's gonna go to the this one metacoin. So should put 10,000 in metacoin in the first account is the test that is failing. It's showing red and things like that, right? So here it will say assertion error. 10,000 wasn't in the first account. That is the error I have given, right? And expected this thing to be equal to 9,000, right? So we told expected is 9,000, and that's the problem here, correct? So that is how our test case will either pass or fail depending on the first and the second values, okay. Next comes our should call a function that depends on a linked library, right? So these are all async and await, because you know that a blockchain will take time to do a transaction, correct? So here I'll do metacoin.deployed similar way as we did earlier. Then you will say metacoin instance.get balance.call of the first account, correct? And then in Ethereum balance, get balance in ETH, that calls the library and everything, right? So if you give let's say the first account, right, and the first account has 10,000 tokens balance, In Ethereum, right, in Ether, right, when you pass the amount and conversion rate, it's gonna multiply, right? What is it doing here? Just sending the balance and 2. So it's gonna multiply by 2, correct? So here you can say Metacoin ETH balance, which will give 20,000 according to us, and 2 into Metacoin balance, that is also 20,000. 2 into 10,000, right? Should match with each other. If it is matching, then which means that the Metacoin ETH balance function is working, which in turn means that the this thing convert lib is working, correct? So as we have seen, that also works perfectly fine. Then we are checking should send coin correctly. Okay, so Metacoin instance equal to await Metacoin dot deployed, right? And you can say const account 1 equal to accounts of 0, account equal to accounts of 1, right? Account 1 and 2 I'm taking. First I'm getting the balance of these two. So probably this will give you 10,000, this will give you 0, correct? And then I'm transferring 10 tokens from account 1 to account 2, right? So I'll say send coin to account 2, how much is the amount? And then of course these two will be the arguments to the function, and this will be the account from which gas price will be deducted, correct? Once you send coin, we'll again say ending balance, right? So once the transaction happens, this will become 9990 and this will become 10, correct? Now we'll just assert dot equal both the conditions, correct? Once these two matches, then it is done. So this is how you write test cases for a particular project, right? So what I can do now is to show another contract, right? If you go to this front end, right, front end is created using this React box, if you remember. Okay, so let's go to the front end and look at the test that is written here. Okay, shall we probably reconstruct this entire thing so that you can get a hands-on experience, right? So what has been done here? Okay, anyway, so we don't need to do that, we can do it ourselves, right? So here I can say const contract instance, right, is equal to, right, simple storage dot deployed. Okay, so this is how I get the contract instance of the simple storage, correct? Once I get the instance, I can say await, because it's going to take time, async await. Okay, contract instance dot simple storage, where is my contract? This is the one I have set and get. Okay, so contract instance dot set whatever number I want to set, right? Number, or is it okay unsigned integer? So I want to set, let's say 25, right? But this will be a send function because of uh, what do you say, the gas price and transaction and everything from, let's say, accounts of 0. Is accounts being passed in? Yeah, no problem. Okay, so once this is done, right, I'm gonna call the get function also, right? What do I compare it with? Let's see, await contract instance dot get dot call. Yeah, so I'll do this and then I'm gonna do assert, right? Assert dot equal, what's happening? Assert, right? Should A be capital or something? Right. Let's just do this. Assert dot equal, right? What is the this thing? Let me add it in inside a const and say balance. No, value. Let's call it. Okay, value is equal to await. So value, comma 25, comma I'll give a this thing which says value is not as expected. Okay, hopefully this works. Let's see. If I go to the front end and open a terminal there, right? Let's say truffle test. I'm sure I've written everything fine. Let's see. Await, not a problem. Truffle config does not match with the network. Okay, some network issue. Go to the config and check what is there. Develop 7545. Okay. Network ID I have to change. Network. Uh, how do you give network ID in truffle config? Just check this. I can also actually copy this entire thing. It doesn't matter. Right. Okay. This should help me do it. So truffle test. It will say compile all the contracts and then it will start testing. So first is test simple storage, that is written in Solidity code, right? This is the one, yeah. And then simple storage, okay, it says contract instance dot set is not a function. Why is that the case? One passing, one failing. Should store the new simple storage dot set is not a function. Like that. Contract instance dot set, correct? Okay, so looking at this entire thing. Oh, okay. I haven't waited till it is getting the deployed function. Okay, let's see if this works. Truffle test again. Every time it's gonna compile and it's gonna take time, but it's okay. But this is how you will learn, right? How to do things. So test simple storage. Most of the time when you get an error in development, right, it's all about small problems that you have made, right? Dot send is not a function. Oh, okay. Set of 25 dot send is not a function because that is how we do it in Node.js, not in testing. Okay. Oh, fine. Okay. This has to be done in a different way. Let me just comment it out, show you the other method. Okay. It's not a different method. That's how you have to do it. Okay. Once you say set, right? Set is the function. You will say the first argument goes here, and then the second argument or the from account and things like that will go as part of this itself. Okay. So this is one unique way of writing a test script using this thing. Right? Now it should work most probably. Here you understand the difference. Set of 25 dot send is used only in Node.js, not here. Okay. So truffle test it again. This we saw in our MetaCoin example also anyway. If you do test simple storage, that is a solidity testing file, it is going to anyway come in. And get.call also is not a function. Okay, makes sense. That sounds nice. Okay, wow. Set is written like this and get is oh, okay. So you should just say get because it's a view function. There is a specific way that you write it in plain vanilla JavaScript. But if you use Chai or Mocha and these kind of frameworks in JavaScript testing, right? That follows a different method altogether. Anyway, so if you are a tester interested in unit testing, you can focus more on this, right? But as a developer, it's good that you know testing, but you will not. This will not be your primary task. Oh, finally I've stored it. But should store the value 89 is not a good way to describe this. So let me change it to 25. Right. Change it to 25. And that's how I can run my test and say my test script that I have written is working now. So with this, what I'm doing is I'm testing both the set function and the get function, right? So that you can definitely do. Okay, so that is how you do set and get. Remember, this varies a little bit from the Node.js thing that we looked at, but that's perfectly fine, right? So only thing that we want is the test script should be fine. And once you start writing, let's say 4 or 5 test cases like this, you'll be able to get it for sure, right? Perfect. So that is our unit testing for Solidity smart contracts and how Truffle is helping you do this unit testing very easily, right? Hope you enjoyed this session. Let's see you in the next video.